Take a look at the opener for 3.2. In 3.1, we talked about our 4 different types of angles whenever your transversal comes down. When that transversal comes in, it intersects your 2 lines and it creates 2 groups of angles. You have this group from the top, in this case, and the group from the bottom, in this case. Essentially, corresponding angles are angles that when you would make those 2 groups overlap, right, they would be on top of each other. So if I look at angle 1, when I bring angle 1 down, angle 1 and angle 5 would overlap. So they are corresponding angles. Angle 2 and angle 6 would end up being corresponding angles. Angle 4 and angle 8. And finally, angle 3 and angle 7. Right, those are your corresponding angles. It doesn't matter what your lines look like. One line could go this way, and the other line could go this way. If my transversal comes down through, even looking like that, this angle on the top left, this angle here, those are still going to be known as corresponding angles. However, when these lines are parallel like they were in the opener, these corresponding angles, as well as the other types of angles we've been working with, will have certain relationships that we need to be aware of. The first one, for corresponding angles, when your lines are parallel, your corresponding angles will be congruent. Right, and if you take a look at example 1 then. In example 1, it says the measure of 3 of the numbered angles are going to be 125 degrees. Identify the angles and explain your reasoning. Well, the first one that we can pick out, just because we just went over it, that 125 degrees and angle 7 are corresponding angles. So angle 7 will have to be 125 degrees because it was corresponding to the 125 degrees. Now, the other thing we have to keep in mind, we reviewed this in 3.1, vertical angles, such as angle 1 and the 125 degrees, or 5 and 7, they would always have to be congruent too. So angle 1 will have to equal 125 degrees because it was vertical to the 125 degrees. Likewise, angle 5 will have to equal the 125 degrees because it was vertical to angle 7. Right? So just some things to keep in mind there as we go through. So angle 1 was 125, angle 5 was 125, angle 7 was 125. As it turns out, we just found another set of angles that had to be congruent. The 125 degrees and angle 5, those are what we called alternate interior angles. Alternate interior angles will also be congruent when your lines are parallel. So if lines P and Q are parallel, angles 4 and 5 will have to be congruent. Example 2 is using a 2-column proof to prove what we just went over. We just did it in example form, so I'm not going to make you do it again. So we can skip over our 2-column proof here. Instead, I'm going to go back to our picture again, that picture we were just working with. There's a third set of angles we've dealt with already, and that would be the angle 1 and angle 7. Angle 1 and angle 7 are alternate exterior angles, and as we just found out, they're going to have to be congruent also. If 2 parallel lines are cut by a transversal, then our pairs of alternate exterior angles will be congruent. Now, our last ones we haven't dealt with yet, right? But we can do so fairly quickly. And I'll just put some numbers in here. Let's make, we'll make this angle 1 100 degrees. That means angle 8 would have to be 100 degrees. Vertical angles are equal to each other. So this angle up here would also be 100. Those linear pairs that we would have down here, they are supplementary, so this angle would be 80. Our last set of angles then are your consecutive interior angles. They are not equal to each other. Instead, they add to 180. They would have to be supplementary. If two parallel lines are cut by a transversal, then your pairs of consecutive interior angles are supplementary. So meaning angle 3 plus angle 5 will have to equal 180. In example 3, it says find your value of x. So we have our parallel lines. I have the 113, I have the 3x minus 4. Those are alternate exterior angles. So they must add together. They must be equal to each other. So 113 must equal 3x minus 4. So we're going to add 4 to each side. So I have 117 equals 3x, and then we divide. We get x to equal 39. Example 4 says a taxiway is being constructed that intersects two parallel runways in an airport. You know the measure of angle 2 is 98 degrees. What is the measure of angle 1, and how do you know? Well, the measure of angle 1 would also have to be 98 degrees. How do we know? Angle 1 had to be congruent to angle 2 because they are alternate interior angles. Take a look at the last independent practice then. It says if the measurement of angle 1 is 105 degrees, it says find measures of angles 4, 5, and 8 and tell which postulator theorem we would use. So angle 4 would be 105 degrees because it was vertical to angle 1. Angle 5 would be 105 degrees because it was corresponding to angle 1. And finally, angle 8 would be 105 degrees. Because it is the alternate exterior angle to angle 1. Now for number 2, it says if the measure of angle 3 is 68 degrees, so if the measure of angle 3 is 68 degrees, and the measure of angle 8 is 2x plus 4, they want you to find the value of x. Show your steps. Well, angle 3 plus angle 4, they form a linear pair. That would have to equal 180 degrees. That tells me angle 4 would have to be 112 degrees. Angle 4 has to be equal to angle 8 because they are corresponding angles. So 112 will have to equal 2x plus 4. We subtract our 4 from both sides. I get 108 equals 2x, and we divide. We get x to equal 54. And there's your homework tonight. Pages 157 to 160, the numbers you see there.